Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in to this video in which we review equations. So by now you probably know what an equation is. We just have an expression with an equal sign. And what we want to do is we want to find a number that we can substitute for the pronumeral, i.e. the letter, to make the statement true. So of course here the answer is x equals 3, because if I substitute x for 3, I get 2 times 3 plus 1 equals 7, which is a true statement. And if I were to substitute x as any other number, I would get a false statement. So what you will have is you will have a pronumeral that's had some things done to it. In this case, we've times it by 2 and added 1 and got 7. So what we have to do is undo what's already been done to the pronumeral to find out the solution. So think of it like when you're getting dressed in the morning in winter. So you would put on your shirt first and then put on your jumper. And then when you get undressed, you have to take off your jumper first because you put it on last, and then you take off your shirt. And the same sort of idea works here with equations. We have to undo what's been done to x in the opposite order. So that means the opposite order to BODMAS. So in the equation up here, x was times by 2 first, because BODMAS means multiplication before addition. X was times by 2, then 1 was added. So when we want to solve, we have to subtract 1 first. We have to undo adding 1 first, because it was the last thing done to x. Then I get 2x equals 6, and I undo timesing by 2 by dividing by 2, and I get x equals 3. So it's very important you get the order of operations correct. Two equations, for example, probably look very similar, but they're not equivalent. They have different solutions. They only differ in their order of operations. So in the first one on the left, x has been multiplied by 7 first, then 5 has been subtracted, then divided by 8. In the second one, multiplied by 7, divided by 8, and then 5 was subtracted. So it's important we do these equations slightly differently. If we get the order of operations wrong when we're solving, unfortunately we'll get the wrong answer. So in the first one on the left, dividing 8 was the last thing done, so we're going to undo that first by timesing each side by 8. So then the next thing that we need to undo is the subtracting 5, and of course what we do is add 5 to both sides. Addition undoes subtraction. And of course the final step is that we undo timesing by 7 by dividing by 7, and we get x equals 11. But when we're doing the one on the right, we're going to do things in a slightly different order. Because the last thing done to x was the subtract 5, we undo that first by adding 5 to each side. And we get 7x over 8 equals 14. So then what I'm going to do is times each side by 8. I'll just let you know, for this particular question, it wouldn't matter if we divided by 7 and then times by 8, or the other way around. We'll get the same answer. That's because division and multiplication are like the same rank when it comes to BODMAS. So if we go my way and times each side by 8, we get 7x equals 112. Now we're going to undo timesing by 7 by dividing by 7. So x is 112 divided 7, which is 16. So note here the different solutions. X equals 11 and x equals 16. But the only thing we did differently was undoing things in a different order. So really important you get the order of operations correct. Now let's have a look at solving some word problems using equations. So let's look at this example here. I divide my chocolates amongst my 4 favorite students. And that's probably the 4 students who watch this video, because not many people watch my videos. And I will have 3 left over. If I had 79 to begin with, how many did each student receive? Now, I know that this is one you could probably solve without equations, but I thought it would be good to have an easy one to show you how we can set up equations. So, when we're solving word problems, you always let x, or whatever letter you choose, be what you're trying to find. In this case, I want to know how many chocolates each student received, so that's what I'm going to let x be. So after I've defined my variable, the next step is to write an equation. Basically, I rewrite the information in the question, but I write it only using mathematical symbols and numbers. So I want to say 4 lots of chocolate plus 3 left over gives me 79. So now I've turned this worded problem into an equation that I can solve just like the ones on the previous slides. And from here it's really easy. Step 3 is just solve it. You know what to do. Undo adding 3 by subtracting 3 from both sides. And then we undo timesing by 4 by dividing each side by 4, and I get x equals 19. So just to show you've really understood the question, and it was a worded question, let's write a worded answer. I was asked how many chocolates each student received, so I should write a sentence to that effect. So therefore, each student receives 19 chocolates. Now, of course, I don't have favourite students, but the first 4 people who can contact me and say the word always, you can receive a chocolate for doing this question. You will be the students I'm talking about in this example. All right, let's go and do one more example that's slightly harder. So please pause and copy down this example if you need. Let's look at this example here. Length of a rectangle 3 more than double its width, perimeter 42 centimeters, and we want to find the area. So there's a few mistakes that people would normally make here. First thing they would do is let A equal the area. I understand why you want to do that, but let's think about it. How do we find the area of a rectangle? We need to know its dimensions. So instead of actually looking for the area explicitly, what we're going to do is implicitly, we're going to find the dimensions of the rectangle, and that will tell us the area. Okay, so let's find the dimensions. So a lot of students would then say, okay, cool, let's let L equal the length and W equal the width. That again is another mistake. Why? Because we don't want to define 2 variables, 2 pronumerals. We don't know yet how to solve equations that have 2 pronumerals. If you look at all the other equations we've done in this video, they have all involved one and only one pronumeral, which is usually x, and that's what we need to do here. So, not going to define 2 variables. Instead, when you're finding 2 things, let x, or whatever letter you choose, be the smaller quantity. So in this case, the width. It's just easier if you let it be the smaller one. So now we want to write the length in terms of x, so we don't have to introduce another pronumeral. So the length is 3 more than double the width. So double the width plus 3, and then you get the length. So now we've got both of these things defined using only one pronumeral, which is what we want. So now we can set up the equation. So the perimeter of a rectangle is 2 times the width plus 2 times the length, and we're told that that equals 42. So when you have an equation in which the pronumeral is in more than one spot, you need to first get it to one spot. So let's expand the brackets. 2 times 2x, 2 times positive 3, and let's collect the like terms. And now this equation is really easy to solve. What you do is subtract 6 from both sides, and then divide by 6, and you get x equals 6. So, are we done? No, because the question asks what's the area, and we haven't found that yet. What we have found is x, the width. So the width is 6 centimeters because perimeter's in centimeters. So the length would be 2 times 6 plus 3, which is 15 centimeters. So the area is just 6 times 15, which is 90. Let's put that in a worded sentence. So we just write a sentence answer. Area is 90 centimeters squared. Doesn't need to be elaborate. It just answers the actual question. Alright, this has been the luckiest maths teacher in the world. I hope you've enjoyed this video. Have a great day.